Okay, this is a work solution for question 14 of the pure mock paper that we did in June. Hopefully this will make this question a little bit easier for those people that are struggling to understand it. I don't know why my finger has suddenly just appeared in the video. I apologise for that. I'm not going to reshoot, can't be bothered. The shape that you've asked to find the integral of is two parts. It's a sort of U shape and then a triangle. The cutting off point is at x equals 4. So imagine that from x equals to x equals 4, you've got that shape, and then from 4 to unspecified number, you've got a right angled triangle. So the first thing I want to do is do the integral, because that's the easy bit. Integrating between 4 and 2, 32 to the x, the minus 2, plus 3x minus 8. Hopefully you don't need to explain how to integrate. Raise the power, divide by the new thing. Do it between 4 and 2 and you get 10. Okay, hopefully that shouldn't be a problem for anyone. If there is a problem, look at my working, it's correct. The next bit is the triangle. The triangle takes a little bit more intricacy. What have I got to deal with? I'm told that the line L, which is the hypotenuse of the triangle I'm talking about, is the normal to the curve at x equals 4 and y coordinate as of yet unspecified. So let's first find that y coordinate. Both the line and the curve meet at x equals 4. So if I substitute 4 into the original equation, I can find out where the y-axis, so the y coordinate is. I know I'm making mistakes on this in what I'm saying. So if you substitute 4 into the curve equation, you get that y equals 6. So 4, 6 is where the line and the curve meet. And that's why there's a 6 up there. Okay, great. What can I do now after that? Well, I need to find out the equation of L. And L is a normal to the curve at x equals 4. So if I differentiate, substitute 4 into it, I get the gradient of the curve at that point. And then I just use the fact that the line is normal, perpendicular to the curve. So that means that its gradient will be the negative reciprocal of 2. Yeah, so we substituted 4 into the dy dx, got that dy dx was 2 for the curve. So the gradient of the line, which is perpendicular to that, would have to be minus a half. So y equals minus a half x plus c. And now we use 4 and 6, the 6 that we worked out before. Substitute into there, and we can find out what c is. We've finally got a full equation for L. Why do I want to do that? The reason why I'm trying to do that is I want to find out how big is my triangle, basically. And more specifically, where does the line cut the x-axis? Because that will tell me how long the base of my triangle is. How do I find that? I make y equals 0, and that tells me that when y equals 0, x equals 16. So let's have a look at our picture over here now. It's a little bit more detailed than the one we had above. Our coordinate at the bottom, the base of the triangle, is 4 across 0 up. It's 4, 0. It goes 6 vertically, so our kind of vertical side is 6. And we've got a horizontal side that we now know stretches from 4 to 16, so that's a length of 12. The area of this would be a half times height times base. I did it the other way around. Half base times height should normally be. A half times 6 times 12, which is 36. 36 plus the 10 that you got above from the integral gives you a sum total of 46, and that's that.